Your outboard is slowly destroying itself right now. Most boat owners have no idea it is happening. Today we are exposing 5 hidden mistakes that cause catastrophic water pump failure, premature powerhead damage, and lower unit breakdown that gets worse every single season. Mistake number 3, silently corrodes your engine from the inside out. And mistake number 5 has been starving your powerhead of critical lubrication for years without you realizing it. Stick around, because you can fix every one of these in under 10 minutes if you know what to look for. If you're running your outboard in saltwater, brackish water, or even dirty freshwater, and you are not flushing after every single trip, listen carefully. Salt crystals and mineral deposits are building up inside your cooling passages right now, and they are choking your engine's ability to cool itself. So what happens when your outboard's cooling system is slowly getting restricted by crystallized salt and sediment? The answer is catastrophic: overheating and corroded cooling passages. Your outboard pulls raw water through intake screens, pushes it through narrow passages around the powerhead, and expels it through the telltale stream. Sounds simple, right? Except when you shut down without flushing, all that salt water sits inside those passages and evaporates, leaving behind salt crystals that build up layer after layer. These deposits restrict water flow, which causes your engine to run hotter than designed, accelerating wear on cylinder walls, piston rings, and head gaskets. And here's the kicker: restricted cooling also destroys your water pump impeller faster because it is working harder against reduced flow. The damage does not stop at the cooling passages. Salt deposits corrode aluminum surfaces from the inside, creating pitting and weakness in your powerhead castings that you cannot even see until it is too late. Your thermostat housing gets caked with minerals and starts sticking open or closed, preventing proper temperature regulation. So how do you prevent this? Use a flush attachment or motor flusher every single time you come off salt water. Run fresh water through your cooling system for at least 10 minutes while the engine is running at idle. If you have been running your outboard at low revolutions per minute for extended periods thinking you are being gentle on the engine or saving fuel, you are actually doing serious damage. The engine loads up with carbon deposits, fuel does not burn completely, and critical components do not reach their designed operating temperature. So what happens when your outboard never gets hot enough to burn off moisture and carbon buildup? The result is fouled spark plugs, stuck piston rings, and sensor failure. Outboard engines are designed to run at mid to high revolutions per minute, where combustion temperatures are high enough to keep things clean. When you idle or troll at 1,000 revolutions per minute for hours, fuel does not atomize properly, combustion is incomplete, and carbon starts coating your spark plugs, exhaust ports, and piston crowns. That carbon buildup causes misfires, leading to rough running and, in severe cases, complete fouling of the ignition system. Modern 4-stroke outboards with direct fuel injection are especially vulnerable because low revolutions per minute operation allows fuel to puddle and dilute the crankcase oil. You are not just building carbon, you are contaminating your lubrication system and creating a viscosity breakdown that fails to protect bearings and the camshaft. Oxygen sensors begin reading incorrectly because they are coated in soot, throwing off fuel trim and making the problem worse. Many experienced boat owners now run their engines at higher revolutions per minute periodically, even during slow trolling sessions. If you are trolling for walleye or bottom fishing, take the engine up to 3,000 revolutions per minute or higher for 5 minutes every hour. This raises combustion temperatures, burns off accumulated carbon, and keeps the catalyst and sensors clean. Every outboard has sacrificial anodes, those zinc or aluminum blocks bolted to the lower unit and sometimes the powerhead. Most boat owners forget they exist until something goes catastrophically wrong. But what happens when those anodes are completely eaten away and you keep running in salt water? The answer is galvanic corrosion that eats through your lower unit, powerhead, and trim system from the inside out. Sacrificial anodes exist for one reason: to corrode instead of your expensive aluminum and steel components. In salt water, your outboard becomes a battery. Dissimilar metals plus salt water equals electrical current, and that current will destroy metal. The anode is designed to be the weakest link, sacrificing itself so your powerhead, gear case, and trim components survive. But when that anode is 90% gone or completely dissolved, galvanic corrosion starts attacking everything else. You will see pitting on aluminum surfaces, weakening of critical structural components, and in extreme cases, holes that leak water into your lower unit or powerhead. And here's the brutal part. Once galvanic corrosion starts on your gear case or powerhead casting, there is no reversing it. You are looking at welding repairs or complete replacement of major components that can run $3,000 to $8,000 depending on your engine size. Most outboards have anodes on the lower unit near the propeller, but many also have internal anodes in the cooling passages and on the powerhead itself. These internal anodes are the ones most people never check because you cannot see them without disassembly. Check your anodes every 50 hours of saltwater use or at least twice per season. Replace them when they are half gone, not when they are completely dissolved. If you are running automotive oil in your 4-stroke outboard because it is cheaper or more convenient, you need to hear this. Marine 4-stroke oils are formulated completely differently than car oils, and using the wrong one is quietly destroying your powerhead's internal components. So what happens when your outboard runs on oil that was not designed for constant high revolutions per minute, water exposure, and marine combustion byproducts? The answer is sludge buildup, corroded internals, and premature bearing failure. Outboard engines operate under completely different conditions than your car. They run at sustained high revolutions per minute, often at or near wide-open throttle for extended periods. They are exposed to moisture that gets past seals and mixes with combustion gases. They also deal with ethanol-contaminated fuel that breaks down faster and creates acidic byproducts. Marine-specific oils contain anti-corrosion additives that protect against moisture intrusion, detergents designed for high revolutions per minute carbon control, and anti-foam agents that are critical for engines mounted at an angle. Automotive oils lack these additives because cars do not need them. When you run car oil in your outboard, you are gambling with your valve train, camshaft, and crankshaft bearings. The oil breaks down faster under sustained load, fails to protect against marine-specific corrosion, and forms deposits that clog small oil passages in modern 4-strokes. Outboards also run hotter than cars in many situations because they are cooled by whatever water temperature you are running in, not a regulated coolant system. In summer, your cooling water might be 80 degrees or hotter, which means your oil is working harder to transfer heat. The FCW certification on marine oils guarantees the oil meets specific marine engine requirements for shear stability and anti-wear protection. Your outboard's lower unit is sealed and it runs submerged in water every time you boat. Inside the gear case, heavy-duty gears and bearings spin under massive load, lubricated by gear oil that most owners forget exists until something catastrophic happens. What happens when water contaminates that gear oil through tiny seal leaks, or when the oil breaks down from heat and metal particles? The answer is bearing seizure, stripped gears, and complete lower unit failure that can cost thousands to repair. Lower unit gear oil does more than just lubricate. It transfers heat away from gears and bearings, protects against water intrusion, and suspends metal particles from normal wear. But here's what most people do not realize. Even small amounts of water in your gear oil turn it into a milky sludge that cannot lubricate properly. That milky oil means your bearings are running with inadequate protection, accelerating wear exponentially. Water also causes rust on steel gear surfaces and bearing races, creating pitting that generates even more metal particles and starts a cascade of destruction. Factory service intervals often recommend lower unit oil changes every 100 hours or annually, but experienced boat owners change it twice per season, especially if they run in saltwater or hit submerged objects. When you drain your lower unit and see metallic flakes, gray sludge, or that telltale milky appearance, your seals have failed and water is getting in. Here's the critical part. Lower unit oil also tells you about problems before they become catastrophic. When you drain it and find excessive metal particles on the drain plug magnet, that is your early warning that gears or bearings are wearing abnormally. Changing lower unit oil is simple and can prevent a $4,000 lower unit replacement. So there you have it. 5 hidden mistakes that are quietly robbing your outboard of reliability and lifespan. Which of these 5 mistakes surprised you the most? Drop a comment below and let me know.